All right, so I think we are live. A little bit of a delay there. I'm just gonna run through a few checks just to see if it says my microphone's working, but let me have someone confirm that. It is working. Awesome. All right, cool. So this is the first stream for Dungeon Crawl Stone Soup API. So yeah, so this is all for the project on GitHub. And so we have the code. So it's over here in PyCharm. I'm trying to see if I'm also just gonna check the resolution is useful. Okay, that's what I thought. I thought it would be too small. Settings. Here we go. Let's make this 22. And let me see if I can also make the font bigger on the appearance tabs. So yeah, just if you're just joining, just bear with us for a second. Still getting things set up. Okay, I think. Oh. Let me try presentation mode. Okay. No, we don't want that. And now I think I can exit out of it. Okay. This is an adventure for everybody. Let me open PyCharm back up. Okay, so I don't know. I'll try and change this on the left. So you might not be able to see what files I'm looking at on the left here, but you'll be able to see the files as I change them here in PyCharm. So what I have is I have made a Docker image for the web server. So this is one of the newer things that it's actually not even pointed to on the repository here on this, which is, it's one of the updates I'm planning to push tonight actually. So basically if we run our Docker, which I'm doing right now. I was actually trying to get OBS installed on Ubuntu and ran into a whole bunch of last minute issues there. So I've switched over to Windows, and that is okay. Should have this up and running in any second. Okay. So I have this Docker image and I'm setting it up. Okay, so web server is now running. So that's running on a Docker container. And what that means now is that if I go to localhost, so this is Dungeon Crawl Stone Soup running. So this is the web server version. So when you first start it up, you need to make an account for the agents. And it's useful to make 2 accounts. So I'm making one with Midka. And if you're doing this, you just need to use the username and password, whatever you want it to be. For this purpose, it's just running on a server. It doesn't have to be secure or anything. You don't need the email address. And so then if I wanted to, I could just play in the browser here. So it'll take a second to load. And then now I can start to choose my class, Berserker, Short Sword, etc. And now I can play the game, right? This is just normal. This is no different than if you were going to go to, if you were to just Google crawl. Let's do Dungeon Crawl Stone Soup. Click here. And then if you were going to go to play online, now this is the exact same thing, except this is now running on an external server. Whereas, some external server, whereas this is just running on a Docker image on your computer. And because it's Docker, it works on Windows, Linux, everything. It's just great. So this is a server where people are all playing right now. If you're new to DCSS, one thing that's cool about this server and one thing that's cool about the AI that we're going to develop and work on is that there's a spectator mode. So this is somebody just playing randomly, and I'm going to click on their game, and now I'm watching them play. And so it looks like they're checking which runes they have successfully completed. So this guy has 4 runes. It's pretty great. Pretty good start so far. So, right. So we have made an agent. We've made a user and password for this. So we're going to delete this game. So Midka is the one that we're going to use for our agent here to log into. So basically in main web server.py, we have a config file here in the beginning of the main function. And if we go to this config, we'll see that this is where it's connecting to the Docker image. And this is the name and the password. So this name and password is the name and password that you will have used when you go to register a new account on your web server. So that's why we're doing that. And then because it's useful, so right now I'm logged in as Midka, but the agent's going to be connecting as Midka and playing. So it's actually helpful to have 2 windows open, one so you can spectate, and one so that you can jump in and do anything if you need to fix a game or something. I think that'll become more clear in a second. So I'm going to register another person. I'm just going to call this admin. This is just for me to have another account to kind of watch. So right now I'm logged in as admin. And if I go here and I do run, See, now my agent's connected, and if I click this, I can spectate it. And let's see if this works. There's little timing issues, so it doesn't work 100%. Okay, so now we have an agent connected to the web server, and we're watching it. So through the browser, I'm logged in as admin, and yeah, on the browser, I'm logged in as admin, but the agent is connected through the Python code and is playing. So cool. Awesome. And so this is just an agent taking random actions. So this is the setup we have. Another just quick note for those who are interested, when it comes time to like run experiments for AI agents, this seems to be limited to about half a second or a second to take actions. And I think that's mostly just like web server or WebSocket delays that I haven't been able to figure out how to make that faster. But we have another version where you can run it via the command line using ASCII text. And that is much faster. It seems from some initial tests, we can get 500 to 1,000 actions a second running there. So I'm just going to go ahead and stop this agent. And right, this closed here. And I'm going to open a new window just to be able to go in and change the game for, just remove the game. So right now, when you stop the agent playing, it doesn't automatically delete the game. So I log in as the agent and manually just kill that game, which it's a little tedious. Should probably add a little kind of like a special kill function that whenever you stop the script, it actually sends a few messages to go ahead and end the game for you. So what are we going to work on tonight? Let me pull up, I can go ahead and add this into, just so people can see. Let me add this into capture. We'll say this is the Git terminal. I'm kind of new to OBS and everything. Okay, cool. So this little terminal down here is what I'm going to be using. I prefer to use Git on the command line. Yep, well, that was a random agent. So we have a more interesting agent. We actually have a planning and goal reasoning agent that is a little more intelligent about exploring and fighting monsters. And I will run that one in just a second. So I need to, right, how do I have this set up? Okay, cool. Okay, cool. So I'm actually on my most recent branch. So some of the code you're going to be seeing me work on, this is not the master branch yet. So if you were to go download this code and try to run it, you'd have to switch branches. It's just, I'm not guaranteeing things are not broken at the moment. So it's good practice to stay on, other good branches. So if we just check to see where we're at with everything. Okay, cool. I just want to do a git pull because I don't think, okay. I don't always stretch it. Sometimes you have to do a git fetch to see, Okay. Oh, it's in my OneDrive. That's why it's synced. Okay. Because I had pushed something recently. Okay. Let me hide that. Okay. All right. So right now, if we want to change agents, so that was a random agent I had played. Now we have a fast downward planning agent. So if you don't know, fast downward is a planner from some folks that's available, readily, and it is it's just a great off-the-shelf planner to use. So it's supports classical planning, PDDL, planning definition domain language, which is how we encode models. So we've actually have a partial model that I've constructed here. So there's a whole field of AI that does planning, and PDDL is this language to represent planning problems. So you have kind of a definition at the top, and then these are some components, and this is some of the information we have in the current state. So for those of you new to this project, one of my goals is to use Dungeon Crawl Stone Soup to test AI agents, both reinforcement learning agents or agents that operate with feature vectors as their state representations, and also agents that operate with more symbolic relational state representations, which PDDL is one of those. So we have predicates here, which are relations. So we can have cell objects that are related by this relation, and this is saying that cell 1 is west of cell 2. And we can say things like, at certain cells, there are objects like a statue or lava, or etc. And then we can also define movement actions. So here are some preconditions that if we wanted to move or attack north, all of these things need to be true for us to be able to successfully execute the action. Now, this is not complete. There's other conditions in here that are true that we don't have encoded. But this is, even just this parcel information will allow us to generate plans that will make sure that we don't try to move north when we execute these. So if you also post in chat, if you have questions about anything or you want me to go in more detail, let me know. I'm going to try and keep it somewhat interesting. So let's run the planning agent, and you can see it moving. So for the most part, that means we just make this the agent, and let's go ahead and run the script. So, and I can explain a little bit what this one's doing. So this is the farthest I've gotten in making an AI and basically making the API support intelligent agents. So what the agent's going to be doing is, okay, and a crash. Yep, this is development. So for those of you who've joined recently, I had meant to run this on Linux, and I had some technical issues trying to install OBS. OBS crashed on me, so I switched over to Windows, and I'm not sure I have fastdownward installed, which that's pretty important if we want to do the planning agent. So let me go ahead and just check. We have a fastdownward folder. It looks like it's running. What do we got? What do we got here? Okay. This might just be an updated code thing that I did not fix something somewhere. So it's also good. So myself, I haven't looked at the code in a little bit, and this Twitch stream is partly just to allow me to set aside some time to work on this. So let's okay, so this is the function that's writing a PDDL state to a file, which is then how the planner reads it in. And it is complaining. So this function, right, does not take a goal object. But should it? Let me... Checking the git logs now. Okay. Let's coding while streaming is an interesting thing. So we have, so this wants to take a file name and goals. And what we're doing is so the game state object has a few different features. It has an inventory, it has a cell map, which contains all the cells. And is there a remote branch on GitHub where we can follow along? It's a great username, by the way. Yes. So the branch that we're on right now is the traversing multiple levels branch. And I'm actually, while I work on this, I'm actually planning to push to this branch. So, yeah, it is let me make it visible on OBS. So here, there we go. That's a little bit bigger. Hopefully that you can read that. Yeah, so traversing multiple levels. This is the branch that I'm on right now on the GitHub. So if you have any trouble finding that, let me know. Cool. All right. So the game state object has inventory and a cell map and some other information about the player. And so when we're writing the PDDL state for the AI planner to use, we have the different components of the game state object, like the cell map, the inventory, being written out into PDDL chunks, and then we accumulate all of it into a file, and then that's passed to the planner. So this function is not taking the goal. So I know I had made a change recently, and what I want to make sure here is that so I could just call the function without goals, right? Because there's no longer a goals argument, but I need to make sure that goals are still in the object somewhere. So, but I think that what I had done is I had taken the goals out of, so let me just look for goals. Okay, and let me know if you guys have trouble seeing fonts or seeing things. Just let me know. I'm trying to make sure things are zoomed in and stuff. I expect to refine this and get it a little smoother as we go on. So right, well, could just go ahead and try this, right? So this is fixing the problem that it was complaining about. And if there isn't goals in there, I think we will find out. Okay, but yeah, so now we have the issue where, so we're watching the agent. So yeah, it expects to start fresh every time. So in between runs, I, go in there and manually stop it. So let me just do that real quick, and you're not seeing me do that. It's a separate browser that I do it, another incognito window, because otherwise it wants to log me as the same thing. So, but that's what I'm doing. What's the current short-term goal? Right. So right now I'm kind of just getting things up and running, testing out the streaming, all of that stuff, and so the next thing to work on is really the inventory and items. So I have the agent, the most recent feature I have added is the ability for agents to go up and down stairs. The feature before that I had added was getting monster information into the game state object. And so right now in the planning agent, once I get up and running here, it will explore the it has a method for it wants to go to tiles it hasn't been before or hasn't been near before, so it kind of explores more efficiently than random, and then it targets monsters if it sees any, and then every so often it'll try to traverse stairs. But I haven't done anything yet where the agent goes to pick up items, And so there's a little bit of debugging that's going to need to happen with the item representation, etc. So I've written in the, if we go to gamestate.py, which this is a very large file, probably refactored a little bit. So, I've created an item property class that has all the different things that I could find on the wiki about items. And so an item might have a number of these, attributes or properties. And then there is, we have a cell class, a monster class, cell map, and then we have an inventory item class. So an individual item, and so this is the information I'm encoding right now. The name of the item, quantity, base type, and then a list of properties. And this is some code to extract out. Positive or negative there's the item bonus. So if you have a +5 sword, this is being extracted here, and etc. And then for this item, I have an initial vector representation of the item, which is consisting of its item type, the quantity, item bonus, item equipped, and right now just a single property. We'd probably want to add this later to have more properties. And what I don't have here is a get item PDDL representation. So if the agent needs to do any planning where it's considering what item to use. So for example, we could have an agent that wants to generate a plan to go pick up a sword, equip it, and then fight a monster with it, all in the same plan. But right now, that the item related information is not there yet. So that's actually what I was planning to work on tonight. And so now we have this. Must be a string, not a tuple. So, but this is not returning a string. Should I be calling this function? Write PDDL current state to file. Yeah, so this is writing it to the file. And this function is in the, got a lot of things here. This is in the game state class. So we have object strings. So we're getting this cell map data here, and we're writing them out, and then the goal is written here. So I don't think we need this. All we want to write out is the PDDL string. I think that's what this should be. So let me make sure there's a fresh start with the, okay, so, yep, I'm giving a fresh start to our agent, which you can't see right now. And now let's run it. So it's selecting the class and everything, and okay, loaded, okay. But let's see when it starts the plan. Okay. Interesting. Plan could not be generated. So is it writing the file? So this is the game state PDDL file that's being written out. And it's very, yeah, it's very long here. It looks like it should work. You know what? Sometimes this happens when, it's still not complete in terms of all the objects in the game that have been represented yet that I've included. So like I've done things like plants and lava and water, shallow water, deep water, but I don't have everything yet. So sometimes when you start it, you know, most of the time it works, but sometimes there might be like a weird, I don't know, glass walls, for example, might break it. So I'm just going to run this again and see, because there are a lot of plants and stuff. Let's just see if we get a similar problem. Okay. So we're running it, and you know, I'm just gonna delete this gamestate.pwdl file. It's a temporary file. So okay, so still it's not able, plan could not be generated. So we can actually go test the planner. So if we go to agent.py, and so we're in the fast downward planning agent. So where the planner is. So I'm gonna open up a PowerShell, and I'll add this to the OBS in a second so you can see what I'm doing. It's okay. So let's add this to OBS. Okay. Yeah. So, yeah. So what I want to do is, well, first of all, let's get into the thing here. So, and then, so the way the planner, so I'm just using Python, like a process call, to call fast downward, you know, just outside of the system. So this is what it's running here. And so we can just run this ourselves to see if there's any issue with the planner. So let's just check. Okay, Python's working. And so let's just do Python fastdownward.py. That's the planner. And then we need to give it a plan file. And this needs to be the plan. This is the result file name. So we're just going to do like test plan.txt. And then the domain file name. So this is actually, the domain file name is this one. Right, so this is models fd temp files, gamestate.pwdl, and then we have to give it one more, which is the domain file. So if you're new to AI planning, these classical planning problems have both a domain file, which specifies what the state representation contains, the relations, the actions, etc. And then an actual state is an instance of a state, and you always pass that state to a planner to begin with. So let's do gamestate.py. Okay. Okay, so we are getting an error here. Let's just let's run it one more time. Trace back. I'm not used to seeing this. I wonder, let's just check the files that we gave it. So actually, I want to go back to this command. So for Windows, okay. I did not, well, first of all, I didn't give it this. This is important for this planner. You have to give it a search parameter. So here we want to do, we're giving it a heuristic that's based on A star. Oh, what's the last thing here? Oh, that null I think is just, huh. So SIG-X CPU is not available on your plan. This means the planner cannot be gracefully terminated when using a time limit. But I think it's just a parsing error. So let's just double check these files that we're giving it. So, you know, I'm not going to give it a plan file because I think in that case it will just output to the command line. So I think we just need the, did I get the order of these files right? No. So I think that could be a problem, is that it's expecting the domain file first. Wait. Oh, I was giving it the same file. Was I giving it the same file for both? I think so. Oh, I hate, oh my God. All terminal messiness. Yes. Oh my God. I was giving it the wrong file for both. Bear with me here. As you can tell, I don't have as, kind of fresh coming back to this code myself, so. But the domain file needs to go first, and then the state file. And so I don't have that order. So, and let's get rid of the text file. So, right, it's a temp file, game state. Okay, here we go. So, could not, so Adam is specified twice. That might be something we need to work on. But we fixed the parsing issue. No relaxed solution, generating unsolvable tasks. So now, so that was just to check to see if the planner was working. So now we should actually look at what did we ask the planner to do. So let's go back to Midca's. So I'll go ahead and add this to OBS as well so you can see this. Yes. No, sorry, this is the wrong one. I want the other one. Give me 1 second. Oh, right. No, this is correct. This is correct. Okay. So, right. So here, oh my God, I have so many windows. Okay. So here, we're going to go here and we're just going to look at the state. Okay. So this is the state. And what are you guys seeing? Okay. You see that window. I'm going to go ahead and move this over here. Okay. So this is the state that our agent's in. Now let's see what we're asking it to do. We want it to go to cell X -7 -1, which should be all the way over here. And yeah, the better way of doing this actually. How is this distinct from the old QW bot, which I think was an RC file? It is supposed to learn and improve win rate over time. So I just saw your question in the chat, Nublet198. Yes, that's a good question. So my understanding, I don't think that QW, and please correct me if I'm wrong, because I really want to know what they had done before, because they'd done some good work. I thought that was more, well, you know, let's just double check. I thought that the QW bot was written in Lua. So I had gone and looked at this and yeah, so are you guys seeing this? I think I need to make this window. And let's remove both this. Okay, so right, so the QW bot, This is a good question. I think if we look, so this is the RC. Yeah, so I think this file that I'm looking at, qw.rc, this is all the logic for the QW bot, which is amazing that someone like sat out and wrote all of this. This is incredible. This is saying things like, well, I guess this might just be like parsing some useful information or setting some variables. Like if you have rn in the string, then you have, actually, what function is this part of? So this is item resist. So this returns the amount of art propagated by, I don't know what art prop means. Yeah, right. So they're doing, I looked through this, at the beginning when I kind of started this project. So they're doing some equipment valuation and auto pickup. But yeah, so the biggest difference between the QW bot and what I'm doing is that all of this is running in Lua, I think, which means that it's sandboxed in the Dungeon Crawl Stone Soup game. And because of that, so one is I think you're limited in what you can do with Lua, and I don't think you have full access. For example, I don't think you can like read and write to files. So the stuff that I'm doing with this AI planner, where I'm like reading, I'm writing out information to a file, I'm calling another process. Suppose I wanted to get really serious and I wanted to have an agent that's storing its memories over time, and I want to store it in like a database and use like a SQL database or something and run that and have it like communicate to a server and all that. I don't think you get that full functionality inside a Lua sandbox. And so this is all kind of just running within what's available in the Lua scripting for the game. And somewhere in here is literally the there's code to like determine the value of an amulet. And then I think towards the bottom, so this is just a huge file, right? Like almost 10,000 lines of code that like someone wrote this. It's like the most impressive thing I've ever seen. And I'm not really used to, so it's like, updating stuff. Somewhere it's I don't know, sensing danger and then finding good stairs. This is like a function somebody wrote. So they literally have a specific function for Sigmund. So I don't think this is not learning in the same way that the kind of learning I'm kind of hoping we can get for AI agents. Cool. Yes, update stuff. I think now, just for proper attribution and inspiration, we have to have a function in our code base called update stuff, just to pay attribute to the awesome work that the QW bot. I mean, and what's amazing, and really, I'm really being sincere here in that this is amazing because the QW bot, because it provides a really good baseline to test our AI against. So if we can't make an AI that can beat this, I mean, what are we doing? So, I mean, that's the whole point, is that it can learn, and it couldn't learn to be better than a human. So having this, a really good baseline, this is why in AI, what makes a good benchmark domain is having really good baselines to compare against. I think there was like this one board game that's really obscure, but there weren't any grand masters in the world for it. It was too obscure. It was like some mathematician made it. I can't remember the name. And so unlike Go, so if you followed the news, there's a big success in Google's DeepMind being able to write an AI that could beat the world grandmasters at Go. And but for this like obscure game, they couldn't even really test the AI against a grand master because they just didn't exist. So having a baseline is a non-trivial thing, and so we're pretty lucky from an AI perspective to have the QW bot. Okay, so updater. You got it. Okay, so let's get back and try and fix this planner. Plan could not be generated. So what I'm going to do, what's going to help me, is to print out the, I'm actually even just going to set a breakpoint. I think that's going to help a lot. So before we do planning, I want to print out the game state. So this is like setup actions. That is basically like choosing the race and the class and the starting weapon. And okay, we are drawing the cell map. So you know what? I'm just gonna stop it here. And it says that the mid-K agent is running. Let me exit here. So we'll start a new game. And let me check to see you guys are looking at. Okay, cool. Okay, so if we go to, yeah, we have a fresh game. So let's hit debug mode. And let's see what our agent. And what I want to do is I want to be able to see the game state, the ASCII map. So I do draw a map somewhere here. Okay, so we go to console. Okay, I want to step over this. Okay, so this is the map that we're in. Okay, so this is actually really simple. Let's just continue. Okay, it's continuing now. Okay, and now we're having the planning problem. So this is useful. Hopefully it didn't print too. Okay, so this is the state that we're in. Let's just double check the gamestate.pddl. So it wants to be, the goal is to have this is the player right here. The goal is to have the player at cell 0, -4, which is 0, -1, 2, 3, 4. So this is the goal cell. So this should be a really straightforward planning task. And so I'm just going to do a quick thing here to make this more readable. And so let's just do that. Okay, well, I think I can actually do there. Okay, so this will help us look through a little easier. So these are all the cells. These are the objects in the current state. We have right, and so this is saying how cells are related to each other. Because yeah, we haven't done. So someone had asked, what's the short-term goals? Once we get items working in the planning representation, then what I'd like to do is move everything over and start getting agents running using feature vectors. And then once we get feature vectors, some of the kinks worked out, start just applying off-the-shelf reinforcement learning and seeing what they can do. So let's just do a search for player at. We should have, yeah, so the player's at 0, 0. We want to go to -4. We should have a relation in here north of, are the XY offsets on the cell labels always relative to the player's current position? Yes. So the way the cell map works right now, it's relative to the player's position. Actually, is that true? Let's double check that. Let's find cell map. cell map. So player XY. You know, actually, I'm not sure. I don't think so. You know, I'll be able to easily tell once we fix this planner issue. Okay, so anyway, we know this is working. So, okay, I'm gonna go back to my PowerShell, and let's bring that up here so you guys can see it. And okay, let's do what we were doing before. So we're gonna call fastdownward. We're gonna give it the domain. We're gonna give it the game state. And right, we need to give it this search parameter. I might have left this off last time. So I think this is just a star lm cut. Initial state is a dead end. It shouldn't be a dead end. You know, just for a real sanity check, we should go into fastdownward, and it comes with some example domains. So, well, I thought it did. Let's see, does it? Okay, let's look here. I thought it came with some tests. Anything in tests? No. Experiments. Well, okay. Before we could go off and find a game state. We could go off and find a out there example for the planner. I don't think we need to do that. So let me just run it again and see. Stopped without finding a solution. Could not determine peak memory. No relaxed solution. Okay, games. Oh, wait. Oh my god. I'm such an idiot. Okay, this is not PDDL syntax. So there's just a right. So, okay, that function we were writing to the PDDL is not right PDDL. Okay, right. So formatting object init goal. So if we look at gamestate.pddl, yeah, so this is not PDDL syntax. So why is it printing that? If we go to gamestate.py, which is where it's writing it out. Yeah, so object. So let's just look here. It might yell at me. Okay, so object. Yeah, object is this entire list. Huh. Is it because this is already returning us a list? It is, isn't it? It is. Object strings is a list. Oh my goodness. Okay. 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 So this is causing all the problems. Okay. Let's see. This is why this is not in the master branch. So, okay. Let's make sure our agent is fresh, so we can reconnect and have a fresh start. And are you guys... Oh, you guys are still seeing that terminal window. Sorry. I need to be better about managing all these. Okay. Okay, hopefully that's a little cleaner for you. And now let's run it. But I think fast downward is working, so. Okay. Okay, so it looks like it's running. So we, this is great. This is what I wanted to show, a long time ago. But basically we have the agent, and so now it's exploring kind of efficiently. It tries to reach one of the tiles farthest away. As soon as it sees a monster, it attacks the monster. It just picks a monster at random that it knows about, and it will start moving towards them. And these bats fly all around. So now it's back to exploring, and famous last words. Which words were those? Yeah. So now it's doing the exploration planning, and ooh, is it gonna die here? Wow. Okay, well, so usually Minotaur Berserker, because it has horns, it's a really hardy first character. I mean, so I think fast downward is working. Oh my god, yes, famous last words. But it is working, so I'm happy. Glad to have you here, Professor Rowe. If you guys don't know, Professor Rowe has another Twitch stream where he does an AI game programming course. And you should go check that out. It's really awesome. Him putting his stuff on Twitch was part of the motivation for me starting my stream. So if you're curious about AI game programming, he has a really cool course that he's live streaming. You should check that out. Okay. So let's run it again. See what happens. What I want to be able to show is the agent taking the stairs down to the next level. I just want to check that is working. And so, in this case, when the agent dies, you can just run it again. It's very clean, because it'll just start fresh. It's when you need to stop the game and the agent doesn't die. That's when you need to go in manually and quit it. And if anybody is feeling super motivated, they want to contribute. If you wanted to add functionality where it would automatically cancel the game by just sending the Q and the typing in yes, that would be a cool feature. Part of the reason I'm doing this stream is trying to encourage people to check out the code, contribute, do other things, etc. So yeah. All right, so we got the agents exploring. It successfully killed a few monsters. The horns really come in handy here. And if you're new to Dungeon Crawl Stone Soup, so this character's race is a Minotaur, and they have horns, so they kind of get a free attack when they attack sometimes. So this is actually the one of the recommended starting character combinations for new players. So if you're gonna try and play this game, I got my first win on a Minotaur Berserker. Could I have it reload game state if it's there? If the game exists, maybe. Can you, what do you mean exactly, Theo? I didn't 100% understand that. If you could just, elaborate a little bit. Okay, killed some more monsters. All right, taking down this leopard gecko. Okay, so a feature, if you saw, it just had a prompt in the messages at the bottom left here, where it had to press enter. That actually took me a little, to know when to press enter. I had to debug the WebSocket messages. So some of the history about this API is, I really had to spend some time to try to figure out the kind of easiest way, or one of the most, the ideal way to have an AI agent communicate with the game. And so WebSockets just turns out to be awesome. So with a little bit more than a little, but some manual effort, I was able to look at the data that's being sent across the WebSockets and kind of figure that out. So the game state object in PyCharm that represents the state, that's being updated with the messages that are coming in from the WebSockets. And one of the things that's been a little tricky is that partial updates are given. So it's not like the full state of the game is sent every time between every action. That would have made things probably a little easier. Instead, only some of the tile information is sent and other things. So part of the game state object file is just piecing that together to keep a coherent, consistent state. So as you can see right now, the reason the agent wasn't fighting that leopard gecko is that it had a plan to reach somewhere, and it just was going to execute that plan blindly without responding to the fact that there was a monster. So it's only in between generating plans does it consider changing its goal. And so this is actually, having an agent that can stop mid-plan to change its goal, this is kind of a research problem that I've been looking into with goal reasoning and goal-driven autonomy. And that's something we haven't implemented yet here. So, and with later monsters, that could have been a fatal situation. So, does it generate plans every tick? No. So, I have a lot of output here. Let me see if I can reduce some of this output for the next round, and should be able to see the plan. So sometimes it's generating plans up to 10 to 15 actions away. Oh yeah, so check if game state exists. So Thiel, if you're responding to the I'm not sure if you're referring to the game ending. Right, if it can't run if a game exists. So it's not that it can't run if a game exists. It's that if a game already exists and it tries to join, I think we need to add a little bit of code in there to be able to parse this state that is sent from the server. And actually the current parsing code might be fine. It might just be that the setup actions, like choosing the race and the class or whatever, that's kind of hard coded right now. So the agent the code is just gonna force choose this race, choose this class, blah, blah, blah. Don't check any state. Don't it's not checking to see if we're in the menu, right? So if we added a check to see if it's in the menu, that might be enough. And then it could just, check if a game state dump exists. Yeah, that could work. Or it sounds possible. Cool. Got 11 viewers here. Hope you guys are finding this interesting. The questions in the chat are great. Oh, so it generates a new plan when it runs out of actions. Yeah, basically as soon as the plan finishes, the current plan finishes, it runs. Yeah, so now it's gonna keep running. While it's doing this, I'll just go over how the current planning agent is working. So this is just an initial agent we have here. So fast downward planning agent. Basically, the logic for this, which is in the get action function, right? So gets the current state of the world. First, it checks if it needs to press enter. Sometimes there's a backlog of messages down here. I guess you can't see my cursor, but where there's messages at the bottom left of the game that are saying what's happened here. And sometimes there's so many messages you have to press enter, and you can't do anything until you do that. So it checks that, and then it checks to see if the plan is doesn't exist, or it has no actions in it. So right now it seems like nothing's happening, but it's actually fighting the leopard gecko over there. And then I have a little code here. This is not the best thing, but basically every 10 actions, it rolls a dice with a 15% chance probability to try to go take the stairs. I can see the highlighted line. Reminds me of the early StarCraft work. Yeah, thank you. Do cursed items have a chance to come back, or is that set in stone? So, Volta, are you referring to older versions of Crawl that used to have cursed items? Does Crawl not have cursed items anymore? Oh, they're removed from Trunk. Man, they are making so many updates to this game. Every month I go to play Crawl, it's different. It's like now there's no cursed items. That's wild. For those of you who don't know, cursed items, if you pick up a cursed item, you're stuck with it unless you get a remove curse scroll. And a lot of times they're bad items. So, and I like it and I don't like it. Yeah. So Professor Rowe, right now it's executing a long plan it had generated, which is why it's not fighting the monster right now. Or maybe there's some other issue going on that it can't see it. But anyway, okay, going back, I got off topic there. So the logic for this planning agent is that basically every so often it tries to go down some stairs. So that's the first thing it'll try to do if it doesn't have a plan. Which maybe is probably not ideal actually. We probably want to attack monsters, make that top priority. But if we're not going to go check stairs, then we get a monster goal. And so basically this is really simple. It's just taking it's looking at all the monsters around the agent, picking one randomly, and whatever the location where that monster is at that moment, it generates a plan to go there. Now, if the monster moves, the agent's still going to go to the old location of that monster. But most of the time, what ends up happening is it moves towards the monster moves towards the agent, and they start fighting. If there is no monster, it tries to go to a random, non-visited tile that it hasn't explored yet. And, I wrote, some special code there to... Seems like sometimes he walks into walls for a while. Yeah, it could be that it's planning, and maybe the planning is taking a second or two. I have a lot of debug information. I should remove this. Let's turn some of this off for the next time. 'Cause it'd be nice to see what's happening with the planning. So yeah, I don't think we need to list all the monsters. And yeah, monsters was one of the most recent things I was adding, so I had some debug information there. So now it's just sending action, and then we can make sure that we're printing out whenever we do planning. So let's go to the planning agent. Yeah, this is just length target cells. I'm going to remove this too. I don't think we need that. Maybe we'll keep that. That's a single line that might be useful. And so this is where it's generating a plan. I'm thinking that maybe here we could just print out the plan. It looked like it was spamming the move east action when there was a wall to the right, for example. Could be. Is it just passing to heal? No, it's not doing anything for healing yet. Actually, I don't even think that's an action. So for people who are curious, so there's a lot of actions in the game. So, and I have taken the time to encode all of them. So this was just using the manual. So there's moving or attacking in all the directions, resting. This is like healing. And then, even like O and tab and stuff have commands. And so basically we have all of these. So it's like 92. There's technically 92 actions, which that's one thing that makes this a significant domain for research. If you were to just give an RL agent and these 92 actions and just say, hey, go figure out the best policy with this state space, I mean, that's just not trivial. If you're curious about that, go look at like OpenAI Gym, some of their like initial RL agents. They're not going to have 92 actions for like discrete action spaces. Now, still, it's not on the order of StarCraft, but it's still non-trivial to learn a good policy. So, and then basically, this is literally what's sent through WebSockets to the server. So I just have a mapping here that says, okay, we can tell the agent this is what our actions is going to be, and then it knows, okay, this is the message I need to send to the web server. And that's just actions. And if we look at the planning domain file, the only actions we have in here are moving and attacking in each direction. And we have opening doors in each direction. And that's it. So there's no healing, there's nothing else. It's not using OTAB or anything. I don't know if this file is actually used, so it seems like the effect here is wrong. But that won't be true for an attack. Yeah, so right now moving and attacking is overly simplified into one line 46. Yes. Oh, half-eaten scone. You are on the money with that. Yes. So this is one of the things why crawl is so interesting, right? So from an AI research perspective, so we have these actions. So just for everyone, so the file he linked to was, I think it was line 46. Right, it was right here. So he was saying, okay, if you're attacking, right, if you're moving and there's nothing there, then what the effects of this action is saying is that you're going to be in the destination cell. You're not going to be in the cell you were at before you did this action. So this is just saying you're going to be in a new cell. But if you're attacking a monster, you're not going to be in a new cell, right? So what's the right action model here? I mean, the kind of AI research I really want to do is where we have an agent learning this. I want to have an agent learning what the effects are of actions. And in that case, we probably want to have a separate action model for moving and a separate one for attacking. But the thing is that it's non-deterministic. So if you attack an agent, so moving with nothing there, it's deterministic. But if you're attacking and there's a monster, well then, if you kill the monster, the effect, if you kill the monster, is that there's no monster there anymore. But not every time you attack will you one-shot kill the monster. So in some cases, you'll attack and the monster will still be there. Maybe his health points are lower. Maybe that's an effect of the action. But sometimes you're going to attack a monster, you're going to miss, or you're going to fail, and you won't even hit it. And so then there'll be no change at all. So you have an action, but you have at least 3 different outcomes there. And I have a simple PDDL representation here for this action. There are PDDL there are versions of the language that allow you to have conditional effects. So you could learn, with this probability, this effect will be true. Maybe that's the right way to go here, but that's an open question. This starts to feel like Riddle. Yeah, I've only used Riddle a little bit. The thing about Riddle is it's just specified in like Java code, right? I feel like it's not as, I don't know, it's not as, learning it and then writing. I think you'd have to write it out to Java if you wanted to run it, the domain models. Maybe that's not a big issue. So for those who don't know, Riddle is a more recent domain definition language. Thought it was Petito. Yeah, I mean, this is a good question. I will say it's a little far away from where I'm at yet on the API, but yeah, should add this to the list. Okay, so this guy's just been cruising. We're still on level 1 of the dungeon here. So I'm actually gonna. Does the planning agent expand its model of the world as it explores? Well, the PDDL model is fixed. We need an OTab model. I know. I would leave that as an exercise for you guys if you want to go make an OTab model. For those who aren't familiar with the game, Dungeon Crawl Stone Soup, there's like some shortcuts for humans playing the game, and one of the shortcuts is when you press the letter O, it does automatic exploration, and if you press the tab key, it does auto attacking. So in some ways you can just spam those. If there's a monster, you spam tab. If there's not a monster, you spam auto explore, and basically it won't let you do it if you're about to die, but otherwise you can just do it, and you can actually execute a lot of actions that way. I think from the AI perspective, I don't know. I want to make sure the API is fully fleshed out, which is why we haven't. So pretend the problem file gets updated. The problem file. Well, okay, so the state file is constantly getting updated, obviously, to do the planning. But yeah, the model is fixed right now. The model was just hand-coded by me. And yeah, the main thing I wanted to test is being able to write out a PDDL representation of the state and write out like enough that supports planning. So even if the plan execution is going to fail, right, because some of these effective actions aren't like correct, like it tries to attack, there's a monster there. What's more important is that it can at least generate something of a plan that kind of makes sense. And then execution, we're just throwing it out the window. It's just going to execute it blindly, and we'll see what happens. That's a whole other rabbit hole of like designing the agents. So it's funny because right now I'm talking about this planning agent and going over this, and mostly it's just I want to introduce people to kind of where I'm at so far with the code. But the main focus right now has to be on getting all the API features created. So all the fun, intelligent agent stuff like designing an AI, just not there yet. I want to have the API more fleshed out. Okay. And we ran into a problem here. I think, so as you can see, this is the map that it's built up this whole map in its memory, much more than what you were seeing on the screen. And I think there's a timeout issue, which is another thing I need to solve. It might be that there's like another ping pong message being sent between the WebSockets as like a refresher, and it doesn't automatically. I don't know. There's still some web server things. I'm excited to play with the API. Awesome. I know. Philippe almost lost the game there. Okay, so where are we at? It is 8:53. I'm thinking about taking a 5-minute break. And so I wonder the best way to just put up a message. I'm so new to streaming, if you aren't already aware. I'm just gonna do like, this is terrible, but like a notepad thing and put a message on there. So let's just make this so crude. I'll get some fancier graphics and stuff later, but Okay, let's do this and just zoom in right at comment in your code. Yeah, pretty much. So, all right, everybody. Yeah, be back in a few minutes. Just gonna grab a drink and yeah, we'll pick back up. All right. Cool. So yeah, let's go ahead and pick back up. Just catching up on the chat. Wow, a 27-headed Hydra. That's crazy. Okay, so I want to run the agent again with some of the output turned off. And I also want to make sure we're not printing these JSON messages. So, cool. Stream seems to be working. All right. This is neat. Yeah, this whole streaming thing is pretty cool. Okay, what are we doing? This JSON message. Is this in game state? Let's use PyCharm's features. So how do I do this again? Find. Oh no, I do. Oh, I feel like yeah, find in path. Oh, love this. Finds anything. So I think I want to look for just received JSON message. Right, so this is in game connection. Yeah, so I was debugging some server messages here. Might have to turn that back on when we're debugging later. Okay, so unfortunately the agent didn't die, so I have to go back in manually and just reset it there. Just do that. And doing that. Okay. Also, one other thing before we run the agent, let's make it so that it has a higher probability of going for the stairs. Just to double check that's working. So and yeah, this is terrible. You guys should all be ashamed of me for putting this magic number here. This should be a variable somewhere, but you know, this is a simple test agent. That's, you know, basically, so this is not a final agent. Okay. Even when doing research code, it's good to use good software practices. All right, so let's see. Hopefully, okay, nope. Yeah, let me just found a monster cell. Okay, we need to turn some of this off. What is this? Found a monster cell. Okay, yeah. This is a relatively new thing. Okay, what else? Just added monster. Cool. Okay. This we care about. Okay. Yeah, the platform being Windows, we don't need to print that out. Which is that's in the planning agent. Which is here. Yeah. Okay. Ooh, is it gonna like that? Mike, is it able to start? No, it's sending the okay. Let's close that out. Okay, got a fresh game. Run it. Let's watch it. Oh, it's so hot. Okay. All right. Waiting on WebSocket, sending next action. Sorry. Need to turn this off anyway. We don't need this right now. In process player with data. Yeah. In process player with data. Okay, we're gonna remove this. And awaiting on WebSocket. think that, yeah. Yeah, I was debugging some WebSocket stuff. Okay. So I think we took care of that. In process player. Okay, we took care of that. Is it generating the plan? Oh, the messages. Just added message. We don't need to do that, I think. Just added message. Oh, yeah, okay. Don't need that one. Let's leave the adding new items, because I would like to try to make some progress on adding the new items there. And let's make sure the plan is being printed. So agent. So here, it's generating a plan. So we'll just say if plan and linked plan is greater than 0, new plan is for action in plan print yeah, let's just do that. Okay. Except this is self.plan. Ooh, not that one. Okay. Let's make sure we got a fresh run going. Okay. Hit play. Let's watch it. And hopefully we'll get some useful debug messages. Cool. Okay. Sending next action. And so this is the plan. So it's generating some fairly long plans here, as we can see. Northeast, east, 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 southeast, etc. So yeah. So I think, yeah, so it's generating fairly long plans. Let's see what's happening here. I think if it like tries to fight something, if it gets off somehow, it'll just keep executing the rest of the plan. Okay, so it's gonna go downstairs now. All right, we're on the second level. So it's a fairly recent thing I added was making the cell map. Okay, we're gonna die here. Ooh, that's a lot of poison damage. Oh no! Oh my god. Oh no, he still dies. Okay, but he killed the snake. Amazing. Okay, cool. So I feel pretty confident with where we're at. Planning agent is working. That's a lot of text, so I'm just gonna turn this off for now. And what do we need to do? So to make some progress on the API, we need items. So what I'm gonna print out is the item inventory. So let's just, ooh, there's a lot of items. Inventory item. So what I want to do here, well, so I guess, so we need to think a little bit here. Yeah, I need to think a little bit here about So we have items, and we want to make sure, yeah, these items, the information should, even if we're not necessarily going to generate plans immediately, the agent should be able to equip and de-equip or take off items, drop items from using PDDL actions. So let's see if we can, that's what we're going to work on now, is adding those. So first thing is we need a PDDL representation of items. So let's write that. And this is a it's kind of a modeling exercise. So we have this domain file. Yeah, what are we gonna do? Okay, we have types of monster. Oh, the other thing is we want to be able to give items as goals. That would be a great first step, is just having items that are in the state on cell tiles and being able to go pick them up. So we want some simple item information. I think what we want to say is, let's just keep it really simple for now. Item at a location. And we'll give it, so yeah, this is, I have a question. I'm wondering if items have unique identifiers. And this is where I want to look at the data that the web server is sending me. So the data that the web server is sending me. That is in game connection. There's something in here that's processing inventory. No, okay. It's one of the process. No, sorry. This isn't game state. Process. There's a lot. It's process raw state. Inventory, yeah, process inventory. So we have a name, a quantity, a base type. So inventory ID. So this is items that are in the agents. Actually, this is not. Let's not worry about this right now. So actually what I care about is when we process cell information. Yeah, is this being used anywhere? I need to remove this. I think this is just old. Find usages. No usages. Let's delete it. Let's clean house here a little bit, because I've written many versions of trying to parse map information. So okay, let's actually I'm actually gonna make actually gonna go ahead and make a new make a new branch here. This is traversing multiple levels. We're gonna add items now. So I've made some changes. I'm gonna do a git stash to just hold them to the side. Then do a git checkout to make a new branch. And let's call this item pickup goals. Git stash apply. And we'll do git push. And yeah, we'll have to set the thing. Oh, right. Oh yeah, I have 2 GitHub accounts, and the joy of managing, you cannot have, there's something with it, you can't have separate keys. So how do I do this? I think it's SSH add -d. Oh, it's gonna take me a second. GitHub SSH. GitHub add. I think this is all I need. Check for existing keys. So I have. Right. What do I need to do? I think I need to. Yeah, I think I need to do this. Is it really not? Okay. Well, now it's running, I think. Right. Okay. So what I want to do is remove all my identities. Yes. Beautiful. And then choose the one that I need to use, which is not the one I was using before, which I think it's the ID. Oh, really? Is that? Oh, right. I think this just takes that. Yeah, identity added. Yeah. Okay, cool. So I think we're good now. I think I can do a git push. Beautiful. Awesome. All right. So we've got the git working. Okay. Let's go back to this. Let's go back to the code here. Okay. Right. So we're in game state. Process inventory. Where's the, okay, this, I think this is what I need. Process player. Yeah, so I'd added all this stuff recently. Yeah, believe it or not, still have a little bit of work to do on the processing of messages coming from the web server. Is this being used anywhere? It is. Yeah. Okay. Okay. Yeah. That is being used. Process raw state cells. Okay. Calling this function. Okay. So I think at this point, this is where let's just do a debug thing here, and let's debug the agent here and see what kind of state information we're having. Although we do want to, I'll add a debug statement on the fly, so that okay, cool. We got a fresh game, awesome. Okay, so let's run the agent in debug mode. Can I just clear all breakpoints? Also, I don't want to do this. Okay. Debug. Mute breakpoints. View breakpoints. Okay, that sounds great. So I'm running a debugger. Hopefully I think this should work. Okay, there's no items in sight, so this is why. Oh, could not parse domain file. Missing. Error could not parse domain file. Oh, I had started to make a change, I think. Yes, yeah. Of course. Let's leave this out for now. Let's get a fresh game. And let's do it again. And we will, let's watch the agent. And what we want to do, okay, so it's going. We want to go back here and we want to set a breakpoint when we see an item, because I want to see what's in the WebSocket server messages for it. Okay. It's not stopping. Can I not do that? Is it not being called? And it is running, yeah, it's running in debug mode. So it's called here, process raw data. This is being called, right? Process raw state. And update process raw state. Yeah. Yeah, this is where it's running. Okay, well, let's try debugging it with the breakpoint entered from the beginning. And I think that's the one we, yeah, that's the one. So, well, let's just rerun it. Okay. So that breakpoint's not being triggered. Where is it actually? Game state 1153. Huh, it's not being triggered. Interesting. Is update being triggered? Process messages. Is this being called? Yeah. Okay, this is being called. But there's no items. So let's just skip through a little, see if our agent can survive this kill. Ho ho, we're level 2. Awesome. Okay, there's items now. Okay, beautiful. We have a sword and probably a corpse. Okay, so if we step into this, step over a little bit, I want to see what this cells data contains. And I know this font's really small. I wish I could. That's something I'll need to do, is to figure out how to make these other windows in PyCharm, other than the editor, a bigger font. But yeah, for now. Okay, so we have all these cells, and what do we have here? So this is where the player is. Negative 16, 13. You know, am I printing out this? No, I'm not. Okay. So we got 92 tiles. Or messages that are being sent. So I think in the ASCII representation, that's gonna help. Let's print the state, because I think it's just gonna be a dot. Is the ASCII. Believe it or not, that's part of how I identify. Yeah, so negative 15, 14. So if the player is at negative 16, 13, then this should be 14, 15. And the x should be the same. So I think, unless this is outdated somehow by 1. Huh. You know, there's multiple items. So this is an instance where the web server doesn't give you everything. So even though we can see a sword here, it may not actually be showing up from the WebSocket messages. So you know what I want to do actually is, yeah, not sure what to do here. Okay. Let's see if the agents, let's see if we can get to a state where it will be on top of a tile. Actually, I don't want to do that. Okay, I died. So, just thinking, we were working on items, but one of the things I had added recently was player information. So we could see about adding a goal to heal if the agent does not have full health. Let's do that. That might make it run longer, and just another feature we can add. So change that for later. Let's add player health. And this is a modeling choice, but basically, you know, let's try and do this the proper way with integers. So player health current is going to be a number. You know, actually, I need to double check. So fast downward fluent example. So so far we've been mostly working with symbols, but now we want to work with integers. And I want to see if PDDL 2.2. So I want to try and find the language specification for PDDL 2.2. So predicates, functions, derivative actions, derived facts. Requirements, derived predicates. Okay, I want to know about functions. Omitted? So this is then add predicate. Actually, so a great website for planning is planning.domains. And you can use the 5 macro, in which case it's not so bad. Yeah, so that's actually pretty much what I was thinking about doing. What I want to do right now is the player's health information is not stored in the state for the planner. So I actually want the planner to, well, the planning agent to have in the state the fact that the health is less than its maximum health, and then to basically generate a 1 action plan to, press 5 to heal. But as you can see so far, we don't have that yet in the predicates. This is only a partial subset. So I just want to double check I want to do it as like an integer rather than, I could have a symbol that's like low health, medium health, full health. But it's nice to plan with numbers if we can. So this is the editor. I don't want that. I want education. Usually there's examples where I thought there was something. Actually, I think API to planning domains. So actually, if we go to the editor, then import. Okay, yeah, so these are still, okay, this is perfect. So this is some of the fast downward domains that just kind of come with it. This is a bunch of them. And so I'm looking for functions or fluents in the tags here. Action, cost, drive predicates, equality, negative typing. Can it not handle integers? Fluents. Okay, free cell. Okay, beautiful. Let's just pick one of these. Import both. Okay, so this is like the free cell example, which is it's that old computer game. And domain. So we have predicates. Do we not have fluents? I thought this said this had fluents in it, but I don't. Oh. Oh yeah, maybe. Yeah, the cell locations are just move be columns and columns. So it's not listed anywhere here. Do you not have to declare it? Maybe you don't have to declare it. Okay, cool. Let me check this example. Yes. Yeah. Oh, thank you. This is totally relevant. Yeah, so I have not tried fast downward with Fluence, but hopefully it can handle it. So before predicates, they do the functions. Let's do that. So we, wanted to do this eventually. So this is great. All right. So what I'm thinking is we're gonna have player. See, and then they have battery capacity without a value there. Where is battery capacity used? Yeah, half-eaten scone. You're on the money with that. This is actually just what I was looking for. So I think I'm just gonna do player health current and so battery capacity, sample capacity, distance traveled. Are those, they don't have like a corresponding variable next to them. It says condition and at start battery amount rover is greater than 8. So I wish these files were fully defined. I wonder why they're not. Anyway, I think maybe we just want this. And yeah, this is giving a metric. Right. Yes. Having scone. I think yeah. So I think you're right. Because we only have one player here, this is a single player game. I was thinking we didn't need to have like a player thing. And what I was trying to find in that example was, so under like functions, for example, it has the ones with the rover, but then it just has battery capacity, sample capacity, distance traveled, but I don't see those being used actually anywhere else. Like it's not, they're not using any of the conditions from what I can see. So, oh no, distance traveled is used there at the end. Oh, you just increase it. So that's just the variable. Okay, cool. Awesome. I think we're good. I think we're just going to do player health max. And let's just do these two. So we define the functions at the top. Thank you a ton, Heavy and Scone. That's super, super helpful. Okay, so we got these functions. And so then there's derivative action. Does it have to be on a derivative action? Well, so the problem file where it's, oh, init. Yeah, you just say what the value is. Okay, so make a little note for myself here. Yeah. Let me just let me make it just a new scratch file. new scratch file. So we'll just make this text file, plain text. Okay, so basically to do right now is that we're going to, we need to write player current health and maximum health to the game state.pddl file. And then we need to add actions to, we need to add the heal action to the PDL domain file. And then we need to add goals. We need to add new goal capability to heal, to change, to select the goal of current health equal maximum health whenever current health is, let's say, less than 50% of maximum. Can I? Okay, that's not going to automatically truncate for me. So we're going to do these three things. And then hopefully we should have an agent that can heal whenever its health drops to below 50%. Beautiful. Okay. So let's start doing this. Write player current health maximum health to game state PDL file. Okay. So we have game state function, and in this we are writing PDL current state to file. So we have init and goal, and this is right now it's just PDL string, but what we want to get is, I think we want to get all the player information. So let's add a function here, def get PDL player info self, and this is going to return player health information and other stats. But for now, it's just gonna be health. So where do we have all the players? So this is all the player attributes. We have self. Okay, we just have looks like we just have a lot of these variables stored. Yeah, we just have all the player stuff here, what god they're worshiping, everything. So current HP and HP max. I don't know the difference between real HP. Yeah. Let's just do, real HP max. I think that is what the HP would be normally, but sometimes when you're drained, your max health is reduced as kind of a penalty. And so we want whatever the current max health is, not the real one, I think. So we have these, and yeah, I think that, so we're going to write it to PDDL. So let me go look at the init. How did they define them? Yeah, so it looks like it's nothing more than, so player PDDL strings is equal to this list. And let's just, I don't know if there's necessarily a better way to do this, but we can just say that, so in PDL, we want to say that the player, how did I define it in the planning domain? Player health current. So this is what's going to go here. And we're just going to set this equal to whatever the value is. So player current HP. And then we're going to do the same thing again for HP max. And let's just double check that we get it right. And do this. Awesome. Okay. So we just need to return this. And then in the init, I think we want to do this plus get PDDL player info. And that should take care of that and add it for us. Okay, so if we go to a scratch, I think one is done. Now we want to add the heal action to the PDDL domain file. Okay. So we have all these actions. Let's add action heal. So now we'll call this full heal. And parameters, I don't know if it needs any parameters. Let's see. Does it need any parameters? So in the example you sent, yeah, I don't think it needs any parameters. I think we can just say in the conditions. So for example, precondition. Yeah, let's do and. I think it's just that we want to say that. So we want to do a full heal if the player. Oh yeah, this is at the top of the file. So if the player's current health is less than the player's maximum health, I think this is the only condition we care about. Because if it's full health, don't do a full heal. It's not going to do anything. So precondition, and now we want to do effect. And let's just assume, because it is a full heal, let's just say the effect is that. Now see, it's interesting here because yeah, so you have to remember the effects of these actions are only relevant for planning and for to know if we've reached the goal. When it actually executes, it's going to be whatever it is. So these effects aren't exactly grounded in what's actually going to happen in the game. So, but I don't think that matters. The goal, right, to do a full heal is that our health is equal. So I don't think it's. I need to find out if there's an equal operator. Is it like the predicate equal or PDDL 2.2 equal functions? Yeah, is this going to work? Typing, sum of action costs. Okay, I actually liked. So if we go to PDL 2.1, did we put fluence up there? No, we didn't. We should put fluence. Duration inequalities. Numeric fluence. Derivative actions. Derivative inequalities. God, I wish it would just list them all. Yeah, Yeah, let me see here. So we have greater than, less than. I mean, we could just try it out. I mean, I'm so tempted to see the greater than the less than. You know, I have to imagine that this should work. So, and you know, what I want to be able to do is to say, be able to specify this is my goal. And the planner can just know that just needs to execute this single action. And then, okay, we've added this action to the, isn't that ambiguous? It could mean the current health increases or max health decreases. It's true, but I don't think, so this is the model for the full heal action. So this is just saying, the preconditions are just saying when is the full heal action applicable? Like in what conditions of the state can we take this action? And if we do take this action, what will be the change in the state? So it's not saying how it's going to happen, actually. It's just saying before and after. And so I think your question has to do with the how. And yeah, I mean, maybe that if our current health, if our max health decreases, that's, you know, I think that's something we'd have to solve somewhere else. But that's a really good question. Hopefully that made sense. Okay, cool. So let's, what do we have here? We have this action. Okay, we've done this. We actually need to we need to connect PDL action to the web server action. And I forgot where this happens. So I'm gonna go to the agent, planning agent. And get plan from fast downward. So it's just writing the goal, and then there's a translation step. So what am I doing here? I'm saying, yeah, I'm reading in the plan. So the PDL action name has to match the command names exactly. That's how I'm doing it. So these are the command names, and we want to do the rest and long wait. So this is what we need. If we want to use our current code, this is what I need to call this. But I can rest and long wait action. So hopefully I should be able to add a comment. This, I think it's pretty obvious what this does. Okay. So we've taken care of 2.5. And now we want to add this new goal capability. So going back to the planning agent. Planning agent is over here. The goals. So get first monster goal, get random, non-visited normal player add goal. Okay, let's add a goal. Def get full health goal. And I think what we want to do is we want to say if self, well, you know, before I do this, let me check to see how the goals are actually being called. So this is in the next action. So basically it says, so it tries to get a monster goal. And if that fails, then it's going to try and visit somewhere. So I think what we want to do is we before this, we want to add in else if, let's do game state dot player current HP is less than self, or yeah, let's do self dot game state dot player max HP max divided by 2. So if it's less than 50%, then we're going to do a full heal. Otherwise, we will continue and try to explore. So in this, so here we're going to call this new goal function. And we're just going to assume that the conditions for us wanting to choose that goal are going to be true. So we're just gonna assume it'll just, we ask it for the goal, it's gonna give us the goal. Is it self? Yeah, it should be self. Is this self.game state? Is that not right? Self.current game state, that's what it is. Okay. Right. Okay, so now I think this is as simple as this is going to be. This is going to be that condition, which I'm guessing right now that it's this double equal sign. If it doesn't work, we might try the equal. Like the actual word equal, but this is literally going to be the effect of the action in the planning model. So it's literally just going to be this. Okay. So it doesn't like that. Why does it not? Oh, it might be static. Yeah, sure. No, I don't care. You can yell at me. So I think that's everything we did. I think, let's just double check. So we added the goal. Okay, also, how is this not throwing errors? Oh, maybe these functions are being called. Okay, so we have it here, selected goal. Selected goal is then, oh no, we need to call the planner. Right, we need to call the planner. Is this the same in every case? I feel like, oh, we're calling the planner first. Might need to refactor this code a little bit later. This is not the most consistent between these three if clauses, but we're mostly just checking the health capability here. So, okay. I think we're about ready to run it. I mean, I feel like I should test something else, but let's just, is there a previous game? Nope. Okay, the agent died. That's great. So let's just run it and see what happens. It's probably gonna break and yell at us. Not agent.py. Wrong. We're gonna run main web server. Okay, let's see if it'll heal. 100% chance this works on the first try. Ooh, I love your confidence. Love your confidence. Oh, yeah, well, I was getting that error last time. What is that? What is that nonsense? Oh, something with the domain file. It doesn't like it's yelling at us. So action. Did I there might be a closing parenthesis. Yes. Oh my god. This parenthesis is not being defined. And so it's mad at us. Okay. Hopefully this will fix it. Let's refresh the game here. Okay. New game, and let's hit play. Okay. That doesn't count. That doesn't count for the first try. That was just us fixing the domain file. So if once it gets to a place where it has lower health. Also, yeah, this doesn't count either. What? Fluence? Oh no, the planner doesn't like fluence. Yeah, see, this is where unsupported operand types for none type int. So, well, let's try. Well, just to be super safe here. But actually, I think this error is good for us. We can just check to see if this and this, basically, if they're not none, then we will also do this if statement. Because I think a parsing error or something because of the planning system. Yeah. Oh, this assertion error. This is, I feel like this is where you have to go read about fast downward. Fast downward fluence. You know, okay. If we go to this planning.domains editor, right, then we should be able to import, right, fast downward, all problem suite, right? So if we do this, oh, wait, cancel. Okay, so now we have these, right? And some of these have fluence. At least one of them did. Fluence. Free cell is supposed to have fluence. Now, it might be an error that I have strips. Does this have this doesn't have, oh, this is a state file, the domain. So requirements, it's just strips. I liked that thing you had pointed to earlier. Okay. Derivative actions, fluence, duration inequalities. Do we need this? Maybe we just need that. You know, I don't see strips here. Wait, do we even need strips? Okay, let's try this though. And let's just clear out the agent. And let's try to run it again. Oh wow. Yeah, I knew. Yeah, I should have kept. You know what? We're gonna keep. Yeah, it's better to have this fail the way it was failing. We're just gonna reset that back. Just reset that back. That ends up hiding the error from us. So making a new game, and then let's go. Okay, what error are we getting? unsorted types, non-type int, but are we getting a planner failure? Oh. Maybe we should keep it. Yeah, let's keep it from what it was and then see if we can debug this error. Okay, resetting. Oh, whoops, I don't want to play. Yeah, so it's in this while loop. Goal is none. Oh, I know why. Yeah, we should let's just do it all together. That's let's see, is that gonna fix it? No, it's still on one line. Yeah, let's just do it all together. The else of that if statement, I think, is what was causing this. So okay. Yeah, Havian's going. Yeah, that's what I was thinking. Okay, yeah, here we go. So we're still getting this assertion error fluence in the translate.py. Okay, let's, what we really should have done from the beginning is go to fast downward and figure out, which fragment of PDDL does it support. So it aims to support 2.2 level 1 plus the action cost requirement. For definition of the various levels, see page 63 of the paper, PDDL 2.0, an extension of PDDL for expressing. All right, let's go find this paper. So scholar.google.com. I'm guessing this is where it will be. Beautiful. This is a journal paper. Downloading it. All right. So it said page 63. Let's jump ahead. Oh, this is at the end. 61, 62, 60. Okay. Well, it's not in the citations. So here's a table of all the requirements. But I thought it was something about levels. Basic strip style adds and deletes. We do want strips, right? So if we go to the planning model, the fact that we are, so this is saying we're going to add this fact into the state, and this is saying we're going to delete this fact from the state. So that's what it means by these adds and deletes. Typing, this allows like type variables. So goblin, kobold, rat, slug is a type of monster. It has fluence. So allow function definitions and use of effects using assignment operators and arithmetic preconditions. So what's cool is that it says it does support conditional effects, which is something we could try and do later. So equality supports this as a built-in predicate. So assertion error. I wish I could get a better error message. I have the code here. I could go look at bin translate pdl test.py. Tempted to do that. builds, release, bin, translate, PDDL, test by, because I'm curious how it's parsing. And it's line 63 that it's failing. So let's see what happens. For requirements, assert. Oh, is it just, it doesn't. There's no fluence. That's it. There's no fluence. It says on fastdownward's website it should support fluence, but it's not even in there, right? Unless I'm missing it. I don't see it. Maybe it has another name. Maybe it's ADL. Unless requirements and requirements self.requirements. Is this being passed in? Is there an instance of this somewhere? This is wow, this is a rabbit hole. So we like it it has strips, has ADL, typing, negation, equality, negative preconditions, disjunctive preconditions. You don't think I could just add fluence in there, do you? Okay, so now I'm so curious if is it just not in this version or something, or because if we do go to fastdownward, oh no, I'm sorry. This means that the following major parts of PDDL are unsupported. All aspects of numerical planning. These are introduced at level 2 of PDDL. Exception, some numerical features are part of the action cost requirement. Right. So, okay, cool. So this is just the choice of planner we have right now. And, wow. Okay. So basically the way to get around that for what we're working on now is we are just going to approximate, by having, basically by having like a predicate. So just like there's something like player at, we can just have, so we could just have player low health being true and player full health being true. And so we just can't have like the numbers. So we can't have these functions. But you know, we can still, and if we wanted to, we could also make it so that these, you know, we're basically binning the you know, so let's say the player's health is, the max health is n, and the current health could be any integer from 0 to n, right? But with these labels, we're just going to artificially pick some bin. Let's say low health is less than 50% health, and full health is great, full health is full health. So maybe we have low health, maybe we have high health, and maybe we have full health. So we're just binning, instead of having a range from 0 to max health, we're going to have 0 to 50% is low health, 50% to 99% is high health, and 100% is full health. So that's what we're going to do. And so we're defining these as predicates. And so what's great is that we can have our action here, and we can just say if player, I've forgotten them already. If player low health, then we're going to have that. And so then this action is applicable. So actually, you know what? This should be this, or this should be player. I mean, technically this action is applicable if the player health is not full. So if one of these are true, and the opposite will be, so actually whenever you have ORs, it's kind of funny because ORs, you might just want to have two separate actions. So yeah, this is like a modeling problem. So yeah, that's the question. So let me say this. I don't want to have two rest and long waits here. And because I want this to map exactly to the command that's sent to the WebSocket. I mean, really the precondition is that health is not full. So maybe this player low health, high health is too much. Maybe we should just do player less than full health. You know, there's someone's gonna come along in the future and make a proper AI planning model, but you know, we're just trying to make a demo and test the sockets. So this becomes easier, right? So now we have a bin, right? If health is max or it's not max. So player less than full health. Yeah, it's a little ugly, but player full health. Okay, let's just do this. Let's just do this. And now we kind of have to go back through when we were writing it out in gamestate.py. We were getting PDDL player info. So actually we need to change this. And this is where we're going to do the logic. So we're going to say if self.player current HP is less than self.player HP max, we're going to say, we're going to give it this fact that player less than full health. Otherwise, we're going to give it player full health. Let's double check. It's the right player full health, and that's the same one we used here. Yep, okay. So player full health, and that's what we're gonna do. So now this is really done. Add the heal action, that's really done. Connect the PD action to the web server action. That's already done because we're using the same name as the command. And now the goal capability. So now the goal has to change. It's not going to be current health equal to max health whenever. Well, we can still choose the goal when health is 50% of max health. So that logic's going to stay the same. So if we go to agent and we go to where did I do this? This is agent. Yeah. Okay. So we have those variables and it's less than 50%. I think this is still valid. And then we just want to go here. So this is no longer the goal. The goal is going to be player full health. All right. All right. So this was really, I don't know. I guess maybe it's enough work that maybe we can't count this as the first try. Even though I'd love to be able to do that. So let's try it. Let's see if we can get this work. Be great to end the night on a new functionality. So let's make sure the game is fresh. So we need to make it new. Just refresh the game. And let's try it. Let's see what happens. Ooh. Less than is not supported between instances of none type and none type. Oh. Really? Oh my god. I left that code in there. Oh my god. Terrible mistake. Okay. Let's clear out and try it again. Okay. Let's see what we can do. Oh, is it complaining about wow. Oh, duration inequalities. Okay, domain model thing. It doesn't like this. Yep. We don't need that anyway. It's probably not being used. I'm not sure why I was complaining, but yeah. Okay. Okay. Take 4, is it? We're gonna get there. Okay, so doing old behavior. So we'll have to wait till its health drops, and hopefully it'll find some monsters soon. Cool. Actually, I wish I should have run it in debug mode so I could just pause it when it happens. But we'll see it here, right? In this message here, we'll see if it does the heal. Oh yeah. Okay. Well, it might just die. Look at this. Oh my god, Minotaur is a beast. Look at that. Are you kidding me? Oh no, maybe is it gonna die? Is it gonna die? Wow, what a starting character. What's it trying to do now? Oh, it's trying to rest and long wait, but there's a monster. It shouldn't be doing that. Oh, there's some. It's trying. I know. It's trying. So, yeah, I think the game is rejecting it because it's not letting you, which is smart. It's not letting you rest while a monster is next to you. So, well, it looks like the planner is working, but now it's kind of stuck. So this is really an issue with the monsters somehow. And yeah, so the game actually isn't even progressing. So we probably need to add a feature where if like you've taken an action and the time hasn't increased, nothing has changed in the state. And somehow something unexpected is happening. So I'm gonna stop it for now. And I'm gonna make a thing. So first let's commit this. I think this is a deserves a commit. So let's say basically, yeah, first version of healing goal implemented. And just for kicks, we can just run it again. See what we can get. So we just run it one more time. See if we get anything interesting. And this time I'm gonna run it. Yeah. Let's just run it again. See if we can get it. And so future issues to solve, right? Okay. So check if time from the game is, oh, Thin Shark. Cool. If you're just joining us, so it's not my game. This is Dungeon Crawl Stone Soup, but I'm working on an API so that people can write programs to control the player in the game. So the code on the right here, or sorry, the game on the right here. Well, so now it's stuck. Okay, it's not perfect. It's work in progress. But basically what you're seeing is the game being played by a program that I'm writing on the left here. So, but I don't want to do that. So, has changed. If not, we have a problem. So this is a new feature we should add. What else should we check? Cool. So it's fighting the bats. I'm going to take this time to make some changes to the README. So I think this will be helpful for people. Right. Web browser issue. So, okay. I've kind of solved this problem. So web browser via Docker image. If you just... Okay. Oh, died. Slain by a golem. Did it try to heal? Sending next action. Maybe have our monsters visible be part of the state. Yes. I think there was some kind of parsing issue or something with the monsters. Investigate situation where monsters are not being seen. Yeah. Let's I want to do a few, probably going to end this stream in 5 or 10 minutes or maybe a little longer. So I'm just going to keep running the agent for see if we can get at that behavior while I do some kind of admin stuff and make some updates to the README and other things. And if you guys have other thoughts or have any comments on how this went, I'm all ears. So looking forward to continuing to do this every week, and maybe more often. I might stream spontaneously if I'm going to work on it, but definitely going to try and hit that every Thursday at this time mark. So but yeah, let's go ahead and run the agent again. And oh, it died. Yeah, so we don't have to reset. Awesome. So let's get another game going. Okay. Yeah, investigate the situation where monsters not being seen. Let's update the README. So this is gonna, if any of you are curious and want to use the Docker image yourself to get this up and running the same way I'm doing it, I'm adding those instructions now into the README. So okay, here we go. So, oh, whoops, yeah, okay. All right, what do we got? Okay, we got some combat. Should be fighting the monsters. Reach level 2. Ooh, let's see if he dies. Oh, it's not, he's now, okay. Trying to rest and wait. Huh. This is interesting. You know, I wonder if I can just, no, I can't. Yeah. Okay. Let's do another one. Okay. Ooh, it doesn't like smoke. All right, I don't think it likes smoke. It doesn't. Okay, we're gonna add that. Add smoke to the objects that can be detected in cells. So that's a good point. So if we go to game state, yeah, game state, there's a place where we're processing process raw state, I think. Where are we doing cells? This, I think we're cell map, add or update cell. Is this where we're cell map? Okay, yeah, so this is the cell object. And we have all these things, right? But we don't have smoke. So I might be able to do this now. Self dot has smoke. So this thing, a cell can have smoke. How do we know it has smoke? So we're using the ASCII art to determine what is happening with, like, what smoke is, right? So I'm literally just interpreting these symbols to mean different things. So we need to add one for smoke. This, is this, yeah, interesting. I think I had something where if G was something outside of these, where is this function being called? here, values. So if G is in values.key, but if it's not in any of these, if this should really be a chain of if-else statements, I think. No, not always. Ooh, this is a little. Anyway, we'll have to look into this. I'll go ahead and just put a note here. Add detection of smoke. So we just need to figure out what the ASCII symbol for the smoke is going to look like. So that's something we can work on next time. And yeah, let's run it again. See what else. This is kind of how I've been working on this. Just run it, see what breaks, add that to the list of stuff to fix, etc. So okay, let's right, we have to exit out here. Let's run it again. Okay, I want to go back to the README while this is running. And let's see. So oh no. All right. I'm actually not watching it. How's it doing? Okay. Still alive? Beautiful. Yep. Okay. Um, okay. The README. All right, this is our longest run so far. 650 actions. We might hit the timeout. I'm surprised. Oh, what level of the... still on level 1. Huh, I'm surprised it hasn't tried to go downstairs yet. All right, cool. So I've updated the README. I'm gonna push this with Docker instructions. So it's still on this other branch, item pickup goals. I think that yeah. Okay, cool guys. Well, thank you all for joining me. I think we're gonna wrap it up here. And it's good for a session. We got debugged some issues, learned about the fast downward planner, realized that at least the version we have, I think this is the common version, doesn't support fluents. So to do that, we made a model decision where we just used a simple predicate that didn't have a number in the planning model. So for player less than full health and player full health. And still some things we got to work on, but we made some progress. There's a new branch on the GitHub repo, and I've added instructions to the Docker to the README for the Docker. So yeah, thank you all for coming, and definitely be streaming next Thursday at the same time. And who knows, maybe you might catch me kind of randomly on the weekend or something streaming. So hope you all have a great night. Yeah, thanks for coming. And yeah, cheers. Take it easy.